So today I'm going to explain about the relationship between the line voltage and phase voltage in your star connection. So you know the star connection, how the connection is made. So it is like three phases, sorry, three lines are there: the red, yellow, and blue. Okay. So starting of each lines is connected to individual, and the ending of every lines are connected together, and that is denoted as a neutral one. Okay. Now we are going to observe. Already we know what is your phase voltage and line voltage. So So phase voltage is nothing but the voltage which you are calculating from your any one of the line addition to that the neutral one. Okay, if you take a multimeter and you calculating the voltage across the red along with the neutral, otherwise the yellow with respect to the neutral, otherwise one more choice is blue with respect to the neutral. So this is nothing but your the phase voltage. I will represent as VPH. Okay. And what about the line voltage? So the line voltage, I told you have to calculate the potential difference between your two lines. So two lines listens whether with respect to R and then Y. This is one. So they represent here three arrow marks. Okay. So VRY is nothing but one of the line voltage, and one more line voltage you can measure across Y and V. So this is where it represents here. And the third one is VBR. So blue to red, from this end to top. Okay, so this is nothing but your line voltage. Now we are going to observe what is the relationship between the line along with your phase voltages. And now I'm going to draw the phasor diagram. And you know that for a AC supply, I mean three-phase AC supply, three lines are available. So three lines having the phase shift of 120 degree. Yeah. Yeah. Yeah, I'm going to draw. That's why I made a blank words. Okay. So 120-degree phase shift there, right? So I'm going to draw the phasor diagram here. Um, so you know that just represent this as a red. Okay. So this is your the phasor. I mean vector diagram or phasor diagram for the line red. Okay. So VR voltage at the voltage which you are calculating at the terminal R. Okay. And you know that the B is having 120-degree phase shift with Y, and as well as it is having 120-degree phase shift with your B. Okay. So I'm going to draw everything with the angle of 120 degree. Okay. So if you measure from here to here, it is nothing but 120 degree. And this I will denote it as Vy, and this I will denote it as Vb. Okay. And if you measure from here to here, this is also 120 degree. So totally 360, right? So you know that this is 120, 120, 240, and one more 120 degree. This is nothing. So totally 360 degree. Okay. And, so this is the phasor diagram I just drawn. So now we will find the relation using the phasor diagram. I want to find the relationship between your the phase and line voltage. Okay. First I want to write the equation. So what is the VRY, guys? What is the VRY? Please come out. So what is the VRY here? So VRY is nothing but the line voltage which you are calculating with R and Y. So R and Y means these two terminals. And look at the circuit. So this two terminal is connected with two windings. One is the R winding and it is connected together, and then it is having the neutral, and from here the one more winding, that is nothing but your Y, right? So you know what is the potential difference V? Potential difference is nothing but the voltage is nothing but the potential difference between the two terminals. Okay. Now I am going to calculate the voltage across the two terminals and what is the potential difference. So if VRY is mentioning means it's also depends upon your the neutral one. Okay. I am not directly calculating with R and N. I am calculating RY, but in between I am having N. So I will write the equation as VRY is equal to, in vector form I am writing, VRY is equal to VRN, okay, addition to that VNY. So you know as usually how the voltage will be calculated. If two components are available means the addition of two voltage drop across each and every component is nothing but your the entire voltage potential difference. Here winding 1 R1 is there, so there you may get the voltage as VRN and one more voltage is available. Okay, so that is nothing but the line Y and neutral. So I represented VRY is equal to VRN plus VNY. Okay, now I want to find the difference, right? So VNY. So VNY means I am calculating N as positive and Y as negative. But if I am changing the polarity, then what you may get, it will be negative, right, guys? So suppose I will draw here. So you know that DC voltage having one positive terminal and negative terminal, plus minus. Okay, and here I am having a 5 volt. I am taking a multimeter. I am calculating across here and here. Okay, but thing is, in multimeter, two color combination wire will be there. One is a red and black. So red always you have to keep at the positive, and black you have to keep at the negative. Okay, so that it will show this is a red and this is a black. So it will show how much voltage. This is 50 amp. So it will show the 50 DC voltage. Suppose if you change the polarity of the multimeter, so here I am keeping the black and I am not keeping the red and black here. I am changing the wire. Here I am keeping black and here I am keeping the red in the sense. You may get minus 50 because the polarity is changed. The potential difference is one place will be higher, another will be lower. By changing it, it may show wrongly, right? So it will show in negative value, minus 50. Similarly here, if I am changing this V and Y, so that you have to change the polarity as minus V, Y and then it will be equal. Okay, so so if it is, this is 50, if I am changing the polarity means you may get as minus 50. So minus of minus 50 is nothing but 50 is equal to 50. This is what I did. So what I did, V and Y is replaced with minus V Y N. Then only I can able to calculate it. So V N Y is equal to minus V Y. Okay. So if I substitute this in this equation, then how the equation will become? So V R Y is equal to, so vector of V R. So VR, otherwise I can replace VRN. Okay, both are similar. Why? Because with respect to the neutral one I am calculating. So simply I am representing as VR. Now what about VNY? VNY will be replaced with VYN. Okay, so Vy1 I will represent as Vy. So here negative sign is available, so the plus become negative Vy simply. So just remember guys, VRY is nothing but the line voltage. So I am calculating the voltage across R line and Y line. But VR and VY is nothing but the phase voltage, because you can able to observe here I am calculating with R line along with the neutral. Similarly for Y also, neutral along with the Y. After I replacing, it is nothing but line along with your neutral. So I represent minus VYN. So I simply I denote it as minus VY. Okay. So this is one equation. So similarly, so another two voltage are available, right? Line voltage. So how you will represent VYB? So vector of VYB will be represented as VY in similar manner minus VB, and one more voltage VBR. VBR is equal to VB minus VR. So this is the equation. Now I'm going to find out this in the phasor diagram. Okay. Let's see what is the. I will start with the VRY. So VRY is equal to VR minus VY. We know that VR is represented here and VY is represented here. What about minus VY? So minus VY, what I'm going to do? I'm going to draw a line which is opposite to VY. So it represented minus VY. So I will make a dotted line, because I want to intimate, I want to identify what in the, I mean, I want to draw the VRY in the phasor diagram. So in order to identify that, first I know what is the VR. So this is nothing but your VR directly, and as well as the VY is nothing but opposite to your VY I am drawing in dotted line. Okay. Now after drawing this, I want to make a connection between, because VRY is nothing but there is a link between your the red and yellow line. Okay, so I want to make a connection with your red and yellow, which is represented in negative. So what I'm going to do, I'm going to draw a parallel line to each other. If you take at this point, so this is nothing but minus VY, right? You take minus VY, I'm going to draw a parallel line equal to your VR. So VR is a straight line. So I'm going to draw a parallel line. Similarly for VR. So VR also I'm going to draw a parallel line which is equal to your minus VY. So how it will be? It will be parallel like this structure. So where it is intersecting. So where it is intersecting, that point is nothing but VR point. Okay. So I'm going to draw a thick line from here to the intersection. Okay. I have to make a space there. There is it. Right. So this intersection point is nothing but V or Y. So I will denote V or Y using an arrow. Okay. Now we know that from here to there it is 180. Sorry, 120 degree. Okay. And you can able to observe that it that Vy is there, the minus Vy, that, which is available in the negative value. So you know that it is half of the value, right? So this angle will be off of your 120 degree. So that is nothing but your 60 degree. And among 60 degree, you can able to observe that it is off of the value. If the intersection will be in equally divided the angle, so that you can able to easily conclude that this is having the angle of 30 degree. So VRY is nothing but your line voltage which we observe. These three lines are nothing but the VR representing your the phase angle of your red, and VB representing phase voltage of your blue line, and VY representing phase voltage of your yellow line. Okay. Now I can able to observe that the VRY having the angle of 30 degree from your VR. Okay. And now you know that it is form a rhombus like a structure. I will draw here separately. It will be like this. It like this. So what I'm going to do, I'm going to draw the diagonal value. Okay. So if I draw the diagonal here, and it will be a right angle. So you can able to observe this is a triangle, and in top you may get a right angle. Right angle means I will write here 90 degree. And you know that for all the triangle which is having a 180 degree angle inside, if you calculate it, if you take any type of triangle, so it is a right angle, and the remaining will be, this is right angle, right, 90 degree. So if you add the angle of all, I mean three angles together, a triangle, for example, this is your A, this is your B, this is your C. So angle of ABC will be 180 degree. I think you may studied already in trigonometric formula, 180 degree. In this diagram, one is right angle, so 90 degree I got, and another angle is 30. And what about the remaining this angle? This angle will be your 60 degree. So you can use any formula to identify this. And next, I will name it. I will name here. This is your O, and the intersection is your C, and this is your A. As I will draw here, I will write it here. So this point is nothing but your C. This point is O. This point is A. This point is, and where you got 90 degree angle, and here it is 30 degree. So point 30. This is 90. Okay. So using the triangular formula, I'm going to identify the relationship between your line and phase voltage. Now you know that so from B to OA, the angle is 30 degree, right? So that I will write it as B O A. So the terminal, if I am calculating that angle, that is nothing but 30 degree. And you know that in a rhombus, so this value will be equal to this value in a diagonal. So similarly, this value will be equal to this value. Okay. So what I'm going to do, I'm going to make the equation as OC is equal to CB. Is equal to, and I am calculating that the line voltage, right? So VRY is nothing but the line voltage. So I will represent it as VRY, otherwise I will represent as VL. And you know this amount will be twice. So OB is equal to, what is the OB value? So here is one line voltage and here one more line voltage, it is 2. So OC is nothing but half of the value. Okay, so that I will represent as VL line voltage by 2. Why? Because OB is nothing but, if I am calculating this as a VL resistance, the same value will be available at this end. So OB is equal to 2VL, twice the value of your line voltage. If that's the case, what about OC? So OC and CB will be half of the value. Sorry, yes. So it will be OP is equal to line voltage, right? So this is VL means. Then what about your the OC and CB? This will be half of your VL value. So OC is equal to CB is equal to VL by 2. Okay. Now I'm going to use a trigonometry formula. So cos theta. So what is the cos theta? So here theta value is 30 degree. So cos theta is equal to adjacent by hypotenuse. Okay, so what is the adjacent value? So adjacent value, if you take here, if I am calculating, and this is your angle, right? So I am calculating the theta here, and hypotenuse is nothing but the longest end. So this is your hypotenuse OA. So OA is your nothing but your hypotenuse. And what about adjacent value? So adjacent value is nothing but your OC. Okay. So cos 30 degree is equal to OC divided by OA. So what is the OC? OC we know that is nothing but VL by 2. So I will write it as VL divided by, and whole divided by, what about OA? So the OA value is nothing but the VR. So simply I will write it as VR. So I will write in next is cos theta value. So here I will write, so cos 30 is equal to, it's already written, VL, that is nothing but your line voltage, divided by 2, and again one more divided by, so OA is nothing but the VR. Okay, so VR is nothing but the phase. So R with respect to the neutral. So if you simplify this, you may get VL divided by 2 VR. And what about cos 30? So cos 30 value is nothing but root 3 by 2. So root 3 by 2, and 2 get cancel each other, so that finally the relation becomes VL is equal to root 3 VR. So here VL represented what? So VL is nothing but VR by. So that I will change it as VR by voltage is nothing but root 3 times of your the phase voltage VR. And what about the current? You can able to observe here, guys. So if I am calculating the current, in the sense the current which is flowing here, take an example. So talk about the current. So from this point, so current is divided into three. One is the IR and the other is the IY. One more current is IP. So three currents are there. And you know what is the line current and phase current. So line current is nothing but the current which I am calculating. For example, take a RY. So I am measuring the current from this terminal to this terminal. So how I will measure it usually is I will connect your ammeter in series. Okay. So if I am calculating the current using the ammeter from R to Y, and similarly if I am calculating the current with R to N, so this current will be equal. So in a star network, the current, the phase current will be equal to your the line current. So there is a relationship between your the phase current and then line current. So IL is equal to IPH. So this is the connection. So now if you copy this diagram and then later the equation. Now if you start to copy the diagram,